So this is in combination with the area velocity sensor. We are using the Thelmar compound weir, and so this is just a volumetric compound weir. We're using this as our control volume. You can see that it's a 90-degree V notch for the low flows and rectangular for the larger flows. All of our systems, with the exception of I think one, we are operating at the outlet of a pipe that's entering into an open ditch network. So we have we can access that end of pipe, and this is basically just an insert to that. They are available in sizes in your normal sizes, 6, 8, 10, 12, and 15 inches. They also have adapters to house the 15-inch weir in a larger pipe if that is your circumstance, and we have done that on one 18-inch pipe that we have monitored. They're generally connected to a bubbler pressure transducer to record the stage. They don't have to be. If you're just wanting to go out and visually look at it, there are graduations on the inserts themselves, and you can identify a flow. The cost of the inserts are very minimal. $300 for your 6-inch, up to $450 for the 15-inch. The cost comes into play when we start talking about bubbler units, and the bubblers that we put in this, we've been using the ISCO 4230s, and as I said, they're moving now over to the Signature series bubblers, but they're in the range of $4,000, $4,500 a piece. So it is quite expensive. And then you couple that, as I said, for all of our pipes, because we are in that ditch network and are subject to frequent submergence, we do have area velocity sensors sitting in all of our pipes as well. So here's a schematic of our installation. You can see the field main. That pipe is usually 6 to 10, even we've got some 12-inch pipes for those field mains. We go back into the field and we cut that, and we'll put a stick of generally 12 to 20 feet of a larger pipe, whether that be a 12-inch, and we generally use smooth wall or corrugated smooth wall or dual wall pipe, or we'll use SDR in some cases. And we want that so we can get that more laminar flow, and I'll show that control section. I'll show some pictures here in a minute why that's important. And then we have the AV sensor back about 3 feet from the outlet of that pipe, and then you can see where we have the Thelmar insert as it drops into the drainage ditch. So here's just an example of a field installation. As I said, it does require significant excavation, especially if we're enlarging the pipe, which we like to do. Simply because we want to be able to house those instruments and make sure that by putting that constriction on the end of the pipe where we do dam up water to some degree, that we're not backing water up in the field. That was, when we first started to put these in, that was one of the questions that the farmers raised and now we're already talking about doing that intentionally with our drainage water management, but in the beginning stages of this, they were worried that we were going to back water up, and so that's why we have just gone on and put a larger pipe in place. So you can see that on the left-hand photo as we dug back, and then we put this stick of SDR in, and then you can sort of see what that looks like with our sampling ports and access on the two adjacent photos. So challenges, maintenance, and repairs. As I said, when we first started this, we thought we could just go in and cut the pipe and put this in, and you can sort of see how close we were in that left-hand picture. Then in the middle figure, that's what happened. We were close enough, and you get a lot of turbulent flow when we were so close to the small pipe where we connected those, and so that caused some issues. So we've gone back in now and retrofitted everything, and now we've got, in the picture on the right, you can see we've got that smooth laminar flow coming through that device, which is what we're really wanting for our better accuracy. Another issue is sedimentation and algal growth. As you can see on the left-hand picture, the systems that we're dealing with, these tile systems, they are very leaky systems. We do get a lot of sedimentation in some of our pipes, and in those we periodically have to clean out from behind that stop or that dam. The picture on the right, you can see some algal growth build up, and that's something else that we've had to deal with. Primarily, we will open that up. We'll pull the insert out and let that flush out and clean it out when it starts to build up pretty rapidly there. Another issue is submergence. As I said, we do most of our sites are adjacent to open ditches. The picture on the left, you can see that pipe is submerged, and the one on the right, you can't even see the pipe. So that pipe, the outlet of that pipe is about 3 feet below the water surface elevation. So in this situation, and when we start to get submergence, we back up and we use the area velocity sensor. And so that allows us to use the Thelmars for low flow situations, and then once we become submerged, we use the area velocity sensor so we know whether or we can identify that rating curve and the flow rate in that situation. Another one of the challenges and maintenance, I guess, issues we had in the beginning, for those of you who have worked around the pipe industry, a 12-inch SDR pipe is not a 12-inch SDR pipe. That diameter is usually a little bit less than that. Same with a dual wall corrugated smooth wall pipe. Those diameters are not always what they say they are either. There is some fluctuation in that. So maintaining and getting a good seal with this system is important. Once you get that, you're in pretty good shape then. We've put some laminate, some different glues, some rubber gaskets around these in order to get those seals. You will also see that in certain cases, we had it on a couple of issues, and we've just gone on now and done it on all of our pipes. But we've put some stops in, whether those be just some eye bolts that we have in there, as you can see in the left-hand figure, to hold that in to keep water from pushing that structure out in case we did lose a seal, and we just use a cap on the end of the SDR pipe, a PVC cap that's cut out in order to hold that in. So that's a type of some things that you may find with these type systems. But overall, they're very reliable. Like I said, we're using a bubbler system. There's a lot of different vendors that sell those bubblers, and we're recording. Like I said, we take a reading every 10 minutes on these type systems out in the field. We do have the submergence issue, and in that case, we do revert back to the area velocity sensor, which you can't quite see in the picture on the right there. So key points, yeah, the Thelmar itself is cheap, but once you include the bubbler and the AV sensor, it makes this approach quite expensive, to the tune of about $7,000, $7,500 a pipe. You have to have an installation with a long approach is preferred, otherwise you're going to get some turbulent flow, and the accuracy of that data is going to go down quite a bit. Sedimentation and algal growth behind the plate can occur, and when that happens, that can cause issues. The Thelmar, the insert itself, does not work under submerged conditions and requires some other means to measure discharge, and as I said, we're using the area velocity sensor to do that. But if a good seal and stops are installed, the structure, if they're not installed, the structure can float out of the pipe. But again, we're using PVC caps or eye bolts to put in and keep those structures in place in that situation. But like I said, we've and the good thing is these inserts have a mechanism on them to tighten the seal up on them. So it's not been a big issue, but we've had a couple instances where that occurred.